Hello everyone, this is Aparna Shetty, Assistant Professor, Department of CSE, AG Institute of Engineering and Technology. So let us continue with the association analysis, that is module 3 of data mining and data warehousing. Here, in this lecture, let us go through the topic evaluation of association pattern. Now, why do we need to evaluate the association pattern? Because the association rules algorithms tend to produce too many rules. Okay? Many of these rules are uninteresting or redundant. For example, now, suppose we have this rule ABC implies D and AB implies D. Both have the same support and confidence. Hence, this rule can be regarded as redundant rule. Okay. So, we are going to use interestingness measures which can be used to prune or rank the derived patterns. It is therefore important to establish a set of well-accepted criteria for evaluating the quality of association pattern. So, evaluating the quality of association pattern, we have two well-accepted criteria. That is, first one is objective interestingness measure and the second one is subjective interestingness measure, or it is also called as subjective arguments. The first one, objective interestingness measure. These measures can be used to rank patterns. If it will use the term patterns, that means it is item sets or rules, and thus provide a straightforward way of dealing with the enormous number of patterns that are found in the data set. So, the objectiveness interestingness measures are used to rank the pattern. Okay, in such a way we can deal with the large number of patterns or association patterns that are found in the data set. Some of these measures can also provide statistical information. Example, item sets that provide a set of unrelated items or cover very few transactions are considered uninteresting. Example of objective interestingness measures include support, confidence, and correlation. Next is subjective interestingness measure or subjective arguments. A pattern is considered subjectively uninteresting unless it reveals unexpected information about the data or provides useful knowledge that can lead to profitable actions. So, a pattern is called as subjectively interesting only if it reveals unexpected information about the data or provide some useful knowledge which is not known before that can lead to profitable actions. For example, now suppose if we have the rule butter implies bread. Okay, now this rule is a very obvious rule. Okay, and hence this rule may not be interesting despite it is having high support and confidence. Okay, because it is very obvious that if a person buys butter, then he will buy bread. There is nothing unexpected or interesting about this rule. Consider one more rule here. If a person buys a diaper, then he will also buy beer. Now, this is an interesting rule. Okay, this is something that is unexpected or not known before. Okay, that a person buying diaper will also buy beer. This relationship is quite unexpected. Hence, this rule is interesting and it provides several cross-selling opportunity for retailers. Now, finding the interestingness of such rules requires prior domain knowledge. Hence, we can say that the subjective interestingness measure or the subjective arguments requires prior domain knowledge. Next, let us study in detail how to use objective measures of interestingness. An objective measure is a data-driven approach for evaluating the quality of association patterns. It is domain independent and requires that the user specifies a threshold for filtering the low quality patterns. So, objective interestingness measure is domain independent and hence requires only the user to specify some threshold, that is a confidence threshold or support threshold. Using this threshold, we will prune the low quality patterns. Okay, that is the patterns that does not satisfy the minimum support or the patterns that does not satisfy the minimum confidence will be pruned. An objective measure is usually computed based on the frequency counts table tabulated in a contingency table. So, the objective measure uses a table known as contingency table. Let us look at this table. So, this is a contingency table for two items A and B. Okay. Now, this contingency table is used to compute the interestingness of the measure based on the support and confidence. Now, this is the contingency table representing a pair of binary valued variables A and B as shown. Now, we use the notation A dash and B dash to indicate A and B is absent for a transaction. Each entry Fij, okay, is the number of times or it's the frequency of occurrence of that particular item. Okay, so Fij denotes a frequency count over here. For example, F of 1 indicates the number of times A and B both appear in the same transaction. Okay, F01 indicates the number of transactions that contains B but does not contain A. Similarly, F10 indicates the number of transactions that contains A but does not contain B. Okay, and finally F00 indicates the number of transactions that does not contain both A and B. Here F1 plus indicates the row sum, that is, it represents the support count for A. F plus 1 is the column sum or it indicates the support count for B. There are some limitations of the support confidence framework. Okay, they are telling here the classical association rule mining formulation relies on the support and confidence measures to eliminate uninteresting patterns. So we can eliminate the patterns, okay, that does not satisfy the minimum confidence and minimum support and confidence. So this was the approach used by the classical association rule mining algorithm. They used to prune the patterns, okay, that does not satisfy the minimum support and confidence measure. Now first let us see what was the drawback of support. The drawback of support is that many potentially interesting patterns involving low support items might be eliminated because of the support threshold. Okay, interesting patterns but having low support will be eliminated because of the support threshold. Next, let us see the drawback of confidence. Okay, let us see this with an example. Suppose we are interested in analyzing the relationship between people who drink tea and coffee. Now, this is the contingency table. It shows the beverage preferences among a group of 1000 people. Okay, so 1000 is the total number of people. Okay, and 200 is the support count of tea, and 800 is the support count for coffee. Suppose we have the association rule. Okay, tea implies coffee. That is, if a person drinks tea, then he will also drink coffee. Okay. Now, support of this rule is equal to 80%. Okay. Let us calculate the support. That is, support is 15%. Let us calculate the support. Okay, that is person who drinks both tea and coffee divided by the support count of tea. So that is 150. Person drinks both tea and coffee is 150 divided by a person who drinks the support count of tea, which is 200. Sorry. Support is given by the number of time a person drinks both tea and coffee divided by the total number of transactions. So, person drinks both tea and coffee, frequency is 150. Okay, so it is 150 divided by total number of transactions is 1000. Okay, so total number of people over here is 1000. What is 150 divided by 1000? Okay, you will get in terms of percentage 15%. So that is the support, 15%. Okay, next we will calculate the confidence for this rule. Confidence is equal to support count of both tea and coffee divided by support of only tea. So, support count of both tea and coffee is 150. Divided by support count of only tea is 200. So, what is 150 divided by 200? We get 75%. Now, after calculating the support and confidence for this rule, we may see that this is a strong rule because it has a support of 15% and it has a confidence of 75%. So, we may observe that this might be a strong rule. But, let us look over here. Fraction of people who drink coffee, regardless of whether they drink tea, is given by 80%. How it is 80%? So, fraction of people who drink coffee, okay, and does not drink tea is 650. Divided by the total number of or the support count of coffee. Okay, so it is 800. 650 divided by 800 is 80%. So this is the fraction of people who drink coffee regardless of whether they drink tea. 80%. Okay. Next, let us see the fraction of people who drink tea and also drink coffee. Okay. So fraction of people who drink both tea and coffee is 150 divided by the support count of tea. It's 200. So this is equal to 150 fraction of people who drink both tea and coffee. 150 divided by support count of T is 200. So that is 75%. Now we can see here the fraction of people who drink coffee is 80%, but the fraction of people who drink tea also drink coffee is 75%. Okay, so we can see that the fraction of people who drink tea is reduced from 80% to 75%. Okay, so thus knowing that a person is a tea drinker actually decreases his probability of being a coffee drinker from 80% to 75%. Therefore, this rule, that is, tea implies coffee, is misleading despite its high confidence value. Even though it is having high confidence over here, it might be misleading. As we have seen here, okay, a person who is a tea drinker actually decreases his probability of being a coffee drinker from 80% to 75%. It is decreased. Okay, so fraction of tea drinkers who also drink coffee is actually less than the overall fraction of people who drink coffee, right? So fraction of people who drink both tea and coffee is 75%, which is less than the fraction of people who only drink coffee, that is 80%. Okay, so because of these limitations of the support confidence framework, okay, various objective measures have been used. Those objective measures we will be seeing in the next lecture. So here we can see that even though a rule has high confidence, it might be misleading, because actually when we see the fraction of tea drinkers is 75%, the fraction of people who drink both tea and coffee is 75%, which is less than the fraction of people who drink only coffee, that is 80%. So even though this rule has high confidence, it is misleading. Okay, so next topic is measures of objective measures. Okay, next topic is the objective measures. We will be seeing it in the next lecture. So that was about today's lecture. If there is any doubts, we will discuss in the Google Classroom. So that was about today. Thank you.